very happy to follow on Joe's talk because it allows me to focus on the simple question of, so not just focusing on the whole development process, which Joe had outlined is complex, is difficult, lots of steps to go through, and therefore also highly risky, but instead focus on what do we actually do in one of these evidence gathering exercises and how this changes during the pandemic. Joe had outlined already that the whole process from initial development to approval, getting the treatment into the patient can be sort of 15 years or so, which obviously during a pandemic is a problem. And so I'm going to focus on first general principles about how we make decisions about possible treatments, and then talk about approaches and ideas that we've implemented to make sure that we can speed up the process and get answers more quickly as necessary during the pandemic. So I'll start off with a hypothetical example, a very debilitating disease called sudden onset arithmophobia, or SOA. And the typical cause of that disease is that a person wakes up one morning and finds themselves utterly unable to solve even the simplest of mathematical problems. Now, the disease can last a few days, or it can be a bit more persistent, lasting for months or even years. And unfortunately, to this day, there is no known cure. Now, Professor James Moriarty claims to have developed a two-hour hypnosis-based intervention, and he claims it will cure 75% of SOA sufferers, which obviously sounds fantastic. And it raises the immediate question, would you undergo Professor Moriarty's hypnosis therapy to treat that disease if you have it? Well, I'm going to be skeptical, and I'm going to go with Sherlock Holmes, who responded to the question by Watson, what's the meaning of this all Mr. Holmes? To, I have no idea, I have no data, I cannot tell. And so fundamental to making decisions about whether or not we ought to take this hypnosis therapy is going to be the evidence base that we have and the data that underlie that evidence. And what we do in drug development is we try to collect evidence such that we can differentiate between association, like we've seen in the previous talk, association between ice cream sales and polio cases, and identify what the causal triggers of the disease are, and identify whether there's a causal relationship between the treatment that we think is going to be helpful and the outcome in patients. So one of the things we're going to have to think about is what strength of evidence we're going to require and how much evidence in favor we're going to require in order to say, yes, I think that treatment is going to be useful, versus, no, actually, the evidence is not strong enough, or possibly even going against what I thought, and therefore I'm going to go with, no, actually, that treatment is probably not going to be useful for us. Now, whenever we make a decision, and the context here is no different than for any other decision, we're going to have to choose between taking an action or doing nothing. So in the context of drug development, we're talking about, should we recommend this treatment to be used in patients, or shall we do nothing, i.e. stick with the status quo? And for any decisions, what we are going to be worried about is the kind of mistakes that we are going to make. And as a statistician, I'm going to say that we might not have been the most imaginative in naming the kind of errors that we are going to be able to make, or that we could make. The first one is, called type 1 error, and that is thinking about taking the action when actually we didn't need to do anything. There wasn't sufficient evidence for us to say that that treatment actually is helpful. And you can think of it that that error, or this, how much of that error you're going to allow in your decision process, defines how high you set your bar on my previous schematic. The second type of error, and I'm sorry, not very imaginatively called type 2 error, is we do nothing when actually we should have done something. And that, in my world, is controlling, setting an acceptable type 2 error implies how much information, what level of information do we require before we can make our decisions. And so fundamentally, any clinical trial boils down to making the decision, should we say that treatment is useful or not? And what we want to do is we want to make sure that we have acceptable risks of making the wrong decisions, type 1 errors and type 2 errors. So just to give you a flavor of potential errors, and this is an example that benefits greatly from hindsight, was in the news about a year ago now, where it was uncovered that stockpiling protective gear, specifically eye protection for NHS staff, was not deemed to be useful when weighted up against the cost. So in 2017, when there was a call to stockpile eye protection, decision was made, no, that is not going to be necessary. Now, again, with the benefit of hindsight, we can say, oh, would it have been very useful to have that stockpile about a year ago? Yes, of course, it would have been. And therefore, we can argue in this case that the decision that was made at this point was incorrect, that a so-called type 2 error was made in this context, because we would have been better off having the eye protection and then not having it when we needed it a year ago. Okay, so then the other aspect that we're going to have to worry about and have to think about is, so what do we actually base our decisions on? Obviously, there is a multitude of different things that we could be interested in. We could be interested in my SOA example of how frequently a patient suffers an SOA attack. So that might be something to base my decision on. It might be that it's the duration, how long an episode lasts, that we're interested on, and so on and so forth. But in general, the important aspect is that it needs to be meaningful to the patient. It's going to be needed to be measurable reliably. In other words, if I measure the same thing multiple times, I'll get the same or a very similar answer at the end of the day. And it should help me making clear-cut decisions at the end. Typically, in a trial, what we're going to use is we're going to boil all this decision-making down to a single metric, which we call a primary endpoint, and on the basis of which we're going to make the decision about whether or not the treatment is deemed to be helpful or not. Once we've established that, we come back to the question, is the treatment actually better? And the way that we're going to do this in the trial context is that we compare patients that receive our new treatment, our experimental treatment, and compare those against untreated controls. And by untreated controls, I don't mean we don't do anything to those patients. We still give them the standard treatment that we would have given had we not investigated that particular experimental treatment. But we're not going to do anything special beyond that to them. And one of the things that's going to be important is that we want to make sure that our controls, the people that don't get the treatment, are as similar to the patients that receive the treatment as possible. so that at the end of the day, the only possible explanation why there's a difference comes down to the treatment. And so there are a couple of techniques that are particularly helpful in this context. Randomization is key here. It's basically just saying, flip a coin whether a patient, when he enrolls in the study, gets the control treatment or gets the experimental treatment. Including placebo is going to be helpful to minimize biases as well on top of that. So that's a whistle-stop tour of some thinking that's relevant on any investigation related to a new treatment. And so now let's start thinking a bit more about, so what does that change during a pandemic? And I'm going to go back in time a little bit. I'm going to get back to the Western Africa Ebola outbreak a couple of years ago. What you see here in my graph is a timeline at the bottom, and the number of cases signified by two different blue lines, two different reporting mechanisms in the number of cases that have had Ebola in this case. You can see there's a peak of about 500 new infections at around November, December, and then there's a sort of a decline afterwards. Now, the errors signify important clinical trials and when they started. And you can see that the very first clinical trial started just about at the peak of the infection rates. And so you could argue that because it took so long for the trials to start, they basically missed the boat, right? There was no way that any of these studies could ever possibly answer the questions it was set out to do, because the number of cases, in this case, fortunately, disappeared, in this case, without any intervention. But it also highlights, imagine that any of these studies would have started in June already, rather than starting only in November. We would have had answers to possibly several of these treatments, convincing answers of whether or not they would be effective in Ebola. So therefore, when we're thinking about doing a trial during a pandemic, we're going to have to recognize that we're going to struggle with the uncertainty that the new disease brings. We don't know much about the natural history of the disease. We don't know what sort of endpoints are going to be more important than others, and so on and so forth. Yet at the same time, it is paramount that we start investigating treatments as quickly as possible, obviously in order to help patients, but also, and that's linked to the graph on polio that we've seen on the previous talk, it helps with the outbreak response. You saw the introduction of the vaccine, and cases drop down immediately. If we have a treatment for COVID that's available now that's 100% effective, we wouldn't have a problem anymore. The infections would drop down immediately. Therefore, starting quickly is absolutely key. The second aspect to worry about is during a pandemic, the frontline workers are under extreme pressure. They don't have the luxury, like often required in traditional trials, of filling out tables and collection information, filling in forms endlessly to collect the data that is necessary. They need to focus on the patients. They cannot spend the time just collecting information that may or may not be useful. And so streamlining as much as possible is going to be paramount. So with that in mind, what we did when we first heard about coronavirus is think about, let's get a trial started. And so we started the Lotus trial on the 18th of January 2020, at a time where probably most people in the UK haven't even heard of coronavirus before. That is 19 days after the first case of a reported COVID infection. Now, obviously, we had to make compromises. First of all, we hadn't had the luxury of doing preclinical studies, preclinical development, in vitro development to find the tailored treatment that might be perfectly suitable for that virus. We had to go with existing treatment, and the treatments that we went with was lopinavir, ritonavir, which is an HIV treatment, incidentally. It wasn't clear, I guess, what the right kind of primary endpoint was, but we could learn from related diseases. In influenza, an endpoint of change on a point scale is sometimes used, and so we've adapted that endpoint for this particular trial. Is this going to be the most relevant, the best endpoint to be used for a study? I don't know. But at this point, in order to get the study started, I think it was a reasonable choice to make. Now, this trial took place in China, and once it became clear that unfortunately the outbreak wasn't contained to just China, but is going to go pandemic, we had some more time to think about more carefully about what do we want the optimal, the perfect trial to be during a pandemic. And this is an outline of the sort of things that we thought are important. So use meaningful and efficient endpoints, discard poor treatments quickly. So this is already highlighting that we know that most treatments unfortunately do not work. And what we don't want to do is spend time investigating them longer than necessary until we conclude they aren't working. Because there's a multitude of potential treatments available for other diseases that might be useful in COVID, we thought that it was important that the trial copes with multiple treatments. And finally, it minimizes the burden on frontline staff. Obviously, the list went on, and I'm sure everybody that's listening in can add an additional point that's important to them. But to us, those were the sort of four main bits that were relevant. The final bit was the trial needed to be adaptive. It needed to be able to cope with the changing environment, with the changing understanding of the disease, and therefore be able to cope with these additional information as it comes in. So with that, we've designed what's known as the recovery trial now, which is a trial that, again, build on speed, try to make sure that we get answers as quickly as possible on the basis of meaningful information. Just to give you headline figures, it recruited 11,500 patients in the first 90 days, and to date, it's over 39,000 patients being recruited across 180 centers. It's a trial that's open from newborns to, well, no upper age limit. And most spectacularly, the trial went from funding to first patients in 9 days. Now, if you're not working in the trials world, that might not sound so impressive, but I can tell you that this process taking 9 to 18 months is not unusual. Doing this in 9 days is absolutely unheard of. So how did the trial start off? So trial started in the UK on 19th of March of comparing standard of care against 4 different treatments, and all of them treatments that have been used for one or another disease in the past. About a month later, on the 24th of April, the first adaptation to the trial happened. A new treatment called tocilizumab was added to the trial. Another month went by, and a new treatment, convalescent plasma, was added to the trial. A week later, we had the first answer. It wasn't the answer that we were hoping for, but we had the answer that one of the treatments, hydroxychloroquine, doesn't work, doesn't help patients with COVID. Another 10 days later, we had our first winner. We found that dexamethasone was an effective treatment in severe disease. Another 10 or so days later, next answer, unfortunately, another treatment that hasn't proven to be successful. Trial is still ongoing, and I ran out of space on my slide here, so I'm going to cut things short here and tell you that up to this point, the trial has identified 2 effective treatments, has answered 10 questions, so 8 treatments are shown to be not effective, 2 treatments to be shown effective, and most importantly, many, many lives saved in the process of that investigation. Now, am I going to say that this is the perfect trial during a pandemic? Of course not. There's always things that you can do better, but it is definitely an example of an useful way to go through and identify potentially useful treatments. And with that, I'm going to stop.